And I will briefly introduce Kevin Patrick, who's been our collaborator from the very beginning, in proving that those who partner with iDash get successful. He's got two grants linked to iDash, one from NSF and another one from the NIH. So we will briefly talk about those.
Absolutely. A very high-level overview of these two projects, but it's great to see so many smart people working on the infrastructure issues that allow people like me to write grant proposals related to this. So this is terrific to see. So SciCore, the first project, Cyber Infrastructure for Comparative Effectiveness Research. This is a project aimed at addressing the issue of challenges in comparative effectiveness research, which were identified in a report back in 2009. And in particular, this project focuses on the limited focus that CER has on health behaviors, behavior change, patient-reported outcomes, and then also data infrastructure issues, the whole notion of standing up an infrastructure that's reusable in this area. So for this project, this was actually an ARA-funded grant. It was a grant funded primarily to the MD Anderson Cancer Center. They pulled us in to build and work on the infrastructure, and I'll talk about that in a moment. And the focus was on patient-accessible tools for direct entry of data, remote patient monitoring, and sensor management, interfaces to enable researchers to use and understand the data, and interoperability with other systems as well. So again, one of the GO grants. So we were able to hit the ground running on this project because for several years we had been working on sort of a generic suite of wireless tools that capture data from weight and blood pressure, accelerometers, et cetera. And this is only one suite of tools. We've been working on a variety of other things that we've done, and that's the reason MD Anderson approached us, including ecological momentary assessment using mobile phones and mobile video capture and whatnot. So with this suite of tools, we were able to build essentially, and this is sort of the map of the stakeholders and the capabilities. On the left-hand side, capturing lots of data from individuals at home via this hub, and the hub had different types of radios in it that allowed any particular device to be used to pull the data into that hub. And again, mobile phones, to then allow sensor operators, people who operated the system, researchers, clinicians, policymakers, others to actually use this architecture. And we also were able to work with a terrific group of folks to build this services-oriented architecture. Ingolf Kruger was our primary co-PI on this, and has developed this method of rich services oriented architecture that allows decomposition of application services and then pretty robust handling of the infrastructure services. And this is where the interfacing occurs with the iDash group. And so we're able in this project to develop, again, a clinician interface that can be used to monitor what's happening to a particular person during the course of treatment through objective data. Self-reported data can be entered, and an interface that actually allows these types of data to be looked at. And this is fully configurable to allow any particular kind of study to call up any particular type of data. A researcher interface for study management, who gets what sensors, who gets this, how long do they need to be followed, what is it that's actually being done for a particular study, and then researcher interfaces for data visualization. And again, in the interest of time, I'm not going to show a lot of these, but they're essentially sort of plug-and-play modules that we're developing that could fit any particular use case. So the primary use case that was studied under the initial grant for this was head and neck cancer, and this is because of the interest that our colleagues at MD Anderson had in this. Big problem, lots of issues. Head and neck cancer creates, the treatment creates about 8 weeks of just pure hell as far as after the radiation doses and whatnot. And these people are sent home, and sent home often with many types of problems. Mucositis, issues of swallowing, very difficult to even keep them hydrated, which was the primary concern of this particular use case study. So high risk for dehydration rather, and malnutrition. And frankly, many of these folks end up going back to the hospital, either to the ER or to the hospital during the course of treatment. So they felt that this was a high-value target to look at. So the goal is to maximize capability for frequent data collection, to capture these important clinical parameters, integrate and analyze the data to identify high-risk individuals, and then provide some decision support to clinicians who might want to be intervening should they need be. So this is sort of a picture, starting on the lower left-hand corner, a scale to monitor weight loss. That data is transmitted into the hub, a blood pressure and a device that also captured the pulse to pull that into the hub. Video capture of swallowing exercises. One thing they wanted to do was actually get exercises and understand the fidelity with which people were doing their exercises, and also self-reported outcome that could be entered into the phone. All of these things essentially brought up into the the hub or via a cellular network, and then into the interfaces that I showed you a moment ago for the researchers. So this study was a success. It actually worked very well. 98% of assessments completed, 60% of patients had at least one dehydration-related event. And there's a paper that outlines this. I think it's in Journal of the National Cancer Institute. So long story short, high level of clinician, patient, and caregiver support and satisfaction. And that led to the MD Anderson getting an additional full R01 study for this that began this past spring with Susan Peterson as the PI. Simultaneously, we have gotten a 5-year R01 grant to move forward with strengthening this infrastructure and building it so that it can be scaled to additional cancer centers. And this is where our interface, one of our 5 primary aims with this is to interact and intersect this now in a very solid way with the IDASH architecture that you're hearing about to allow data sharing, should that be of interest to researchers, and to bring in additional use cases. So I would say that this platform is here available to have other people write proposals to, should they, if you're interested, let me know. Or let Lucilla know, but there are others. So many thanks to the investigators at MD Anderson and here at UC San Diego, and one of the investigators is at University of Alabama, Birmingham. So now I'm going to jump to something completely different, a different type of project, and this is the National Science Foundation funded project in the Smart and Connected Health portfolio called Delphi. This project is meant to address the question that was raised earlier about the different types of data. So there are lots of different forms of data. So stepping back at the macro level, don't need to tell you folks that this is growing like mad. Lots and lots of different forms of data. All of these data are increasingly the understanding of their importance to health is tremendous, and they all interact with each other at different levels and in different ways, in a continuous way. So how do we wrap our mind around the fact that we've got all of these data and address it? This is important because providing health care and population health requires reasoning across these layers. Just very simply, diabetes management, it's not enough to know what the blood glucose is or the HbA1c. You've got to know where people live, and you also have to know how physically active they are. If you, in fact, ask them to become physically active, are they? Asthma care, a no-brainer here. I mean, you've got to know how people are responding to treatment, but you also have to know environmental issues and what directions of transportation they might take, and just simple things like obesity tracking for public health. If we're really going to understand this, we have to track different types of variables that are often in different locations. So providing access to these is very difficult for all the reasons that we know. They're collected and maintained by different entities. Some collected by the types of groups that we're talking about here today, but many not. You know, Runkeeper or Facebook or Twitter or other sorts of things. Genomic data, although even though it's not happening now, but this notion of people getting their own personal genomic data. So what do we do about this? So the goal of this project is to essentially integrate these into a single uniform database by taking into account geospatial context. If health is related to place, then that's an important thing to build into this. And implement analytics visualization layer on top and open the data up to other folks. So we have partners in this project ranging from Qualcomm to our local health information exchange, to our public health department, to our San Diego Association of Governments, to our local entrepreneurial group, the Connect, UCSD Connect, to get entrepreneurs at the table to help us think about how we're doing this. Because those folks often have the data, the entrepreneurs that are out there. So bringing all these data in to Delphi, this whole health information platform model, if you will, and then opening these data up to folks who are, can we demonstrate how this could be opened up to folks who are building applications for patients, building applications for clinicians, or building applications for population health analysts or people who need to understand data in a different way. And so this whole health information model it intends to model it. It intends to create an interface so that new sources of data can be registered relatively simply and easily. Create an API that actually opens this up to developers who might want to develop applications. And to do this, we wanted to create an ecosystem that developers of normal means could use to actually access data. You didn't have to be a rocket scientist to do this, the person developing the app at home. Analytics layer to allow developers to run common analytics on this, and a visualization layer, and to contribute new analytics or contribute new visualizations into this. And so our use case on this right now is asthma. We're looking at trying to explore how we might bring together different forms of data. And we actually have these different forms of data from a variety of different projects that we've worked with. So we've got data that we're populating the Delphi platform with, and we're building a sample app that could allow people to bring in environmental data, clinical data, pharmacy data, other sorts of things, and to demonstrate the use of this. And I'll show you. Again, Siri, compute the air quality on my route. I want to know what it's going to be like today. So, you know certain routes where people go, and you have GPS readings, and you have air quality readings. But right now, air quality readings are very sparse and in different locations, and you can produce some rough approximation of what somebody might be exposed to. But you can also take these GPS readings, and you can model them using a model. And this picture is actually from a paper that we presented at Wireless Health using interpolation models that allowed us to take different forms of data, but essentially meld it together to come up with a much better estimation of what any particular individual might be exposed to. And you can think about doing predictive analytics this way, or you can think about doing real-time analytics on this. So this is actually a pretty important aspect of what we're working on. Oops. The second use case that we're discussing right now with a major funder is using Delphi as an analytics platform that allows bringing together, again, lots of different types of data that are not normally brought together. Social and economic condition data, health systems data, physical and social environmental data, policy data and whatnot, lots and lots of data. And the colleague that we're working with on this has already done a test case using over 10,000 variables of the California census data. But we're interested in doing this in San Diego so that we can get an understanding of what's going on here. But we can also think about this for asthma, diabetes, cancer, Alzheimer's disease, other forms of things, if in fact we're successful in being able to use this. So why not use existing platforms? They don't scale well to large number of analyses. Data have to be extracted from databases and fed into the standard statistical packages that those of us who trained in epidemiology know about using. And they don't support sensor data analytics. The explosion of wearable sensor data is the big news today. Lots and lots of continuous data at every level of the stack across a lot of people. And so how to bring those things in. So this proposed platform, and again, I'm hearing it a little bit in some of the discussion, that this platform incorporates statistics and machine learning inside the data platform. So we're able to sort of bring this in, pushing the computation to the data and not pulling it out like we typically do in our statistical packages. And then supporting sensor data analytics. We have data scientists that are helping us think through what it is that the models of these data do. And so we can use those models to understand GPS data or activity data or sleep data or other types of things. Again, this is moving in this direction of really trying to model the data, then creates a more functional, and we think, or at least the data scientists think, that this is going to help us do this in a more parsimonious way. Then one final comment, that was my last slide. I would encourage you, because there was a question raised about the wearable data. We have another project that's not yet part of IDASH, but could bump up to it. It's the Health Data Exploration Project. It's a new Robert Wood Johnson Foundation funded project. Hugo Campos was actually on our advisory board for the first phase of this. And so if you Google Health Data Exploration Project, you'll find our website. You can download a copy of the report from the first phase of that project. But we'll be establishing a network of researchers who do work in personal health data. And one of the challenges that we'll be grappling with in this, that has been raised already, is the intersection of these data with the electronic medical record and with other groups. So we'll have some pretty interesting types. I think the name that's probably most familiar to this group is Patty Brennan. Patty is going to be one of our core steering committee members for this project. Pretty well-known person in the area of medical informatics, and someone that you all know. So thank you very much.
Thank you, Kevin. So may I propose that the next 6 people who give 9-minute presentations do come up front, because we're going to do this very fast. Any questions for Kevin while the others are coming up front?
So I have a question. Is this fine? So I'm the one who raised the earlier question. And with personal health data management, which basically would aggregate all these different sources, one of the things that's been lacking, I think, is kind of the model of who owns the data, and also the business model for it. And I wonder if maybe this can become...
It's a huge issue, and we'll be doing, the data ownership is one of the things. Again, if you look at that report, informed consent, terms of use, who owns the data, privacy. There are a variety of things that we found in both qualitative and a little bit of quantitative survey assessment are really going to be key. So we're working on these things, and I think probably working with other stakeholders to at least advance things so that these can be more useful. And those of us who are researchers, I mean, the focus of this is trying to get these data for researchers, but there obviously will have to be a business case. And we have a couple of big companies. Runkeeper will be part of this, Jawbone, others. So with luck, as Tim O'Reilly said, we can socialize some of these companies to begin to open up the data in good ways.
Thank you. So